Hi, welcome back to Missing Chemistry. This is Stoichiometry Lesson number 15. Given 31.5 moles of potassium iodide, which is Ki, how many grams of Ki, potassium iodide, do I have? And what is the percent of composition of each element in the compound? Well, actually, guys, this is a two-part problem, and it's really super easy with stoichiometry. The first thing you need to know is what is the molar mass of potassium and what is the molar mass of iodide. So if we look on a periodic table, you'll notice that the potassium has, and we're going to write that down here. Potassium is going to be 39.09 grams per mole. And again, that is found on the periodic table. All right, and then iodide, which is a different atom, is going to equal 126.90 grams per mole. That's because that atom has more protons and neutrons, therefore it's heavier. That's why there's a difference in the mass of potassium versus iodide. All right, so let's go ahead and table this up together. Since potassium iodide is Ki, right? We have one potassium and one iodide. So we can just add these two numbers together. And we would do that, we get 165.99 grams per mole. So that's our total molar mass for that compound. All right, so we were given 31.5 moles of potassium iodide, and we want to turn that into grams of potassium iodide. So we're going to go from my moles to my grams. It's going to be a one-step conversion, right? So you're going to want to take the molar mass, which is this right here, of potassium iodide, and put that on top. So go to 165.99 grams of Ki. See that? And then we're going to put that over a mole of Ki because the whole thing is grams per mole, right? So moles of Ki will cancel out. So when you multiply 31.5 times 165.99, you get the number 5,000. There you go. 228.685 grams of Ki. And that's a lot of Ki. Now, the second part of the problem says, what is the percent of composition of each element in the compound? Well, we only have two elements. We have potassium, we have iodide, and we know their individual molar masses, right? So this is going to be actually pretty straightforward and simple, because percent of composition is equal to the molar mass of the element divided by the molar mass of the compound. We're going to put element up here. Then you have to do one more thing. You have to times everything by 100 to put into percent, right? So let's look at the percent of K equals the molar mass of K, which is 39.09, right, grams per mole, divided by the molar mass of potassium iodide, which was 165.99 grams per mole. See that? So we just cancel out those grams per mole, and we're going to times this all by 100. And when we divide 39.09 divided by 165.99 and times that by 100, we get approximately 23.55 percent of that compound is potassium. Hey, that was pretty simple. All right, so what we're going to do is we're going to erase and give ourselves a little bit more space up here. So let's go ahead and clear all that out because we don't need this anymore, right? We already know that answer. Okie dokie, we don't need that anymore either. All right, now let's figure out the molar mass percentage of iodide in this compound. So using that same formula, percent of composition equals the molar mass of the element divided by the molar mass of the compound times 100, we can figure this out for I. So K is this number, remember that. That's important to remember. So now with the percent of I, we're going to go, okay, I is 126.90 grams per mole, which was a lot heavier than the potassium, divided by 165.99 grams per mole of the entire compound, times this all by 100. So cancel those grams per mole out again. And now let's go ahead and do the math. So the percent of I is going to equal 76.45. 76.45% of I. And that makes sense because the I has more mass. Now, if we look at this, the 76.45, and if we add that to the 23.55, let's go and do that, see what happens. 76.45 plus 23.55. Remember, this is all in percent, right? That gives us a total of 100%. So we know that we did this correctly. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry.